Hi students, good morning. So in the previous session, we have completed one of the important chapter in inorganic chemistry, that is D and black elements. So in the inorganic chemistry, another important chapter. Here today I am coming with the important chapter, that is coordination compounds. So in that coordination compounds, before that, so I am going to explain about the salt. So what is the meaning of salt and types of salts? So let me take what is the meaning of a salt. So we know that in the laboratory, so we have performed about the qualitative analysis of inorganic salt. So let me take a simple example, calcium carbonate. This is one of the simple salt. So let me take another example. So that is ammonium chloride. That is another salt. So in this salt, so how the salts are formed? Salts are formed by the reaction of acid and bases. So let me take HCl is hydrochloric acid and NaOH, that is a base. By the combination of these acid and base, we will get the salt plus water. So between acid and base in reaction agate, that reaction is called as a neutralization reaction at the end. So here there are two types of salts. So there is one is called as simple salt. So one is called as simple salt, and another one is called as double salt. So what is the meaning of double salt and a simple salt? So before that, so let me take salt is a one which is formed by the neutralization reaction between acid and bases. So number of examples are there: calcium carbonate, ammonium chloride, barium chloride. That is one of the example. Barium chloride. So there will be ammonium bromide. That is also a salt. And also let me take the barium nitrate, NO3 twice. So this is all considered as a simple salts. So why they are called as a simple salts? Then what is the meaning of the simple salt? Simple salt is nothing but a salt consists of one acid radical and one basic radical. Simple salt is nothing but a salt which consists of one acid radical and one basic radical. There is a confusion. So what is the meaning of acid radical and basic radical? Why they are named so? Let me take a simple example. So let me take HCl, hydrochloric acid, plus let me take another one, NaOH, that is called as a base, sodium hydroxide. Sodium hydroxide is a base, HCl is an acid. Between this acid and base, there is a neutralization reaction that forms a salt NaCl plus water. So this is a simple salt, that is NaCl. So when it is dissolved in water, it undergo ionization, nothing but it's split up into two types of ions. So one is called as Na plus sodium ion, and one is called as Cl minus chloride ion. So this is called as basic radical. This sodium plus is called as a basic radical, and Cl minus is called as an acid radical. So why this is called so? Yeah, basic and acid radical. So remember, Na is coming from the base. So Na plus and then that is present in the salt, that is coming from the base. That's why the name is called as a basic radical. Simple. And HCl, so Cl minus, NaCl, Cl minus Cl, that is coming from the acid, that is HCl. So that's why the radical is called as a acid radical. That is a simple meaning. So why the sodium plus and Cl minus are called as radicals? Usually you observe usually acid radical, basic radicals get positive charge. Usually basic radicals are cations, nothing but they have the positive charge. And acid radicals in they have negative charge. Usually they have negative charge. So so carbonate, that is -2, calcium having the charge +2. Here calcium +2 is taken as a basic radical, and CO3 minus carbonato, that is present in the first group acid radical. So that is called as a acid radical carbonate -2. And again NH4Cl, NH4 plus, another one is Cl minus. That NH4 plus is taken as a basic radical, and Cl is taken as Cl minus is taken as acid radical. Like that, in a different cases, one acid radical, one basic radical, that is called as a simple salt. That is the meaning of simple salt, acid radical and basic radical. So now there is another term that is called as a double salt. What is the meaning of double salt? Double salt is nothing but it consists of two simple salts. It consists of two simple salts. And a double salt double is nothing but two simple salts mix are. So double salts are those which are formed by the combination of two simple salts but ಹೇಗೆ ಬೇಕೋ ಮಿಕ್ಸ್ ಮಾಡಂಗಿಲ್ಲ. That is in perfect stoichiometric ratio. In perfect stoichiometric ratio. ಒಂದು particular ratio stoichiometric ratio ದಲ್ಲಿ ಎರಡು simple salt ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ will get a double salt. So what is the meaning of double salt? Double salt is the one which consists of or combination of two simple salts in a perfect stoichiometric ratio. That is called as a double salt. So the double salt ಅಂದ್ರೆ ಎಷ್ಟು radicals ಬರುತ್ತೆ ಸರ್? You will get how many radicals? Acid radical ಎರಡು ಬರುತ್ತೆ, basic radical ಎರಡು ಬರುತ್ತೆ. So ಅಂದ್ರೆ double salts ಗೆ example ಏನು? Simple salts ಗೆ example ನೀವು ಯಾವ್ದಾದ್ರು ತಗೋಬೇಕು. These are all the simple salts. Some of the also for example aluminum sulfate, Al2SO4 thrice. Aluminum has the charge +3, SO4, that is sulfate and the charge -2. So therefore that is considered as aluminum sulfate, formula Al2SO4. That is also a simple salt which consists of a basic radical Al+3 and acid radical SO4 2-. So ಅಲ್ಲಿಗೆ ಒಂದು ಸಿಂಪಲ್ ರಾಡಿಕಲ್ ಅಂದಾಗ ಒಂದು ಆಸಿಡ್ ರಾಡಿಕಲ್ ಒಂದು ಬೇಸಿಕ್ ರಾಡಿಕಲ್ ಬರುತ್ತೆ. ಸೊ ಹಂಗಾದ್ರೆ ಡಬಲ್ ಸಾಲ್ಟ್ ಅನ್ನು ತಗೊಂಡಾಗ it consists of how many simple salts? Two simple salts are present in the double salt that are mixed in the perfect stoichiometric ratio. So based on this, one of the important question is there. So what are the examples for this? So example tagondaga, that is simply FAS. What is the meaning of FAS? That is called as more salt. That is also called as more salt. And what is the abbreviation? That is FAS andaga ferrous ammonium sulfate. Ferrous ammonium sulfate. Ferrous ammonium sulfate. That is one of the double salt, example for double salt. And what is the formula for this? This consists of two simple salts. One is called as ferrous sulfate and another one is called as ammonium sulfate. Ammonium having the charge plus, sulfate having the charge -2. So therefore the formula NH4 twice HO4.6H2. That is the combination. That is the formula composition of the ferrous ammonium sulfate. That is one of the best example for double salt. So what are the simple salts present in this ferrous ammonium sulfate? That is a ferrous sulfate and another one is the ammonium sulfate. So one more example, this is the one example for double salt, and another example is cornellite. Let me take the cornellite. So cornellite consists of how many simple salts? Two simple salts. What are those? One is called as potassium chloride dot magnesium chloride, another simple salt dot 60. This is the hydrated salt. Hydrated salt and the moisture irbekku, that is 6H2O. What are the simple salts present here? KCl and another one is the MgCl2. Potassium chloride and another one is the magnesium chloride. These are the simple salts. By the combination of these two salts in a perfect stoichiometric ratio, we will get the cornellite, and this is the example for double salt. And one more example is there, that is called as potash alum. That is called as potash alum. So potash alum is also one of the example for double salt. And what is the composition? So that is potassium sulfate K2SO4. SO4 charge -2. Potassium is alkali metal having the charge plus. Therefore opposite terminal combination madre K2SO4 dot aluminum sulfate Al2SO4 thrice dot 24H2. So here the two simple salts, what are those? One is the potassium sulfate, another one is the aluminum sulfate. These two are the simple salts. By the combination of these two salts in a perfect stoichiometric ratio, we will get the double salt. And these three are the very simple and very important examples for the double salt. One is FAS, that is ferrous ammonium sulfate. That is also called as a more salt. And another one is cornellite, that is KCl MgCl2.6H2O, and another one is the potash alum, that is potassium sulfate, aluminum sulfate 24H2O. So here there is one of the important question in the combination the CD. So one question up here writing it. So how many moles of ions formed when the 1 mole of the ferrous ammonium sulfate is dissolved in water of the chemical? That is one of the CD question. I think in 2014 batch, 15 batch answer that. So ferrous ammonium sulfate anna dissolve ಮಾಡಿದಾಗ 1 mole ferrous ammonium sulfate ಅನ್ನ ಎಷ್ಟು ions formation ಆಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ರು question. So ಅಲ್ಲಿ ನೀವು ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ these are all the salts, definitely they are dissolved in the water. Just count the number of ions formed. So let me take the first one. So that is ferrous ammonium sulfate. So when they are dissolved in the water, what are the ions formed? The first ion is formed, that is Fe+2, ferrous ion, and one more ion that is called as a sulfate. ಸಲ್ಫೇಟ್ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲೊಂದು ಸಲ್ಫೇಟ್ ಇದೆ, ಇಲ್ಲೊಂದು ಸಲ್ಫೇಟ್ ಇದೆ, ಲಿಟರಲಿ 2 sulfate ions formation. And one more ion formed, that is NH4 plus, that is called as ammonium ion. How many ammonium ions are formed? Let me be taken as 2 moles. So here 1 mole of the ferrous ammonium sulfate, when it is dissolved, when it is under ionization in water, so how many moles of ions are formed? Total count ಮಾಡ್ಕೊಳ್ಳಿ, 1 mole of ferrous ion and 2 moles of sulfate ion and 2 moles of ammonium ion. Totally how many moles? 5 moles of ions are formed when the 1 mole of ferrous ammonium sulfate is dissolved in the water. Similarly, one more question adra ಬೇಕಾದ್ರೆ ಹೇಳ್ಬೋದು, ಕಾರ್ನಲೈಟ್ ಅನ್ನ ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಬರುತ್ತೆ ಸರ್? So ಅದನ್ನ ಈಸಿ ಗೊತ್ತಾಗುತ್ತೆ ನೋಡ್ಕೊಳ್ಳಿ. So K, that is the potassium have the charge plus, it is the alkali metal, and another one is Cl minus. So how many Cl minus are there? So here 1 Cl and here 2 Cl. So totally how many moles? 3 moles of Cl minus are formed. And one more cation, that is called as magnesium, and magnesium is a alkaline earth metal having the oxidation state plus. Again, how many moles of ions are formed? So that is 1 mole of the potassium plus 3 moles of chloride ion and 1 mole of the magnesium. Again, 5 moles of ions are formed when 1 mole of the cornellite is dissolved in water. That is the one more. And one more is potash alum. So how many ions are formed when the potash alum is dissolved in the water? So that like, so you're careful, number of ions just already. So one is potassium plus. Potassium plus. So how many potassium plus are there? 2 potassium plus. Next one is sulfate ion, SO4 2 minus. So ಇಲ್ಲಿ 1 sulfate ಇದೆ, ಇಲ್ಲಿ 3 sulfate ಇದೆ. Totally how many moles? 4 sulfate ion ಬರುತ್ತೆ. So next ನಾವು ಉಳ್ಕೊಂಡಿದ್ದು aluminum. Aluminum having the charge plus 3. So how many moles? That is aluminum having 2 moles. So count the number of moles of ions formed by the combination, formed by the ionization of 1 mole of the potash atom. So that is 2 moles of K plus, 4 moles of sulfate and 2 moles of aluminum. So that is 8 moles of ions are formed when 1 mole of the potash alum dissolved in the water. That's a simple question. 1 mark alli ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಕೇಳಬಹುದು. And remember, so they will not give the any formula. Formula ಕೊಡೋದಿಲ್ಲ, just they will give the name. So cornellite ಅಂತ ನೇಮ್ ಕೊಡಬಹುದು, potash alum ಅಂತ ಕೊಡಬಹುದು, ಇಲ್ಲ ಅಂದ್ರೆ FAS ಅಂತ ಅಥವಾ more salt ಅಂತ ಕೊಡಬಹುದು. ಯಾವುದೇ ಕಾಂಪೋಸಿಷನ್ ಕೊಡೋದಿಲ್ಲ. So just you have to know the composition perfect ಆಗಿ ಗೊತ್ತಿರಬೇಕು. Then only you can write the ions, number of ions formation. ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಚಾನ್ಸಸ್ ಇಲ್ಲ, ಫಾರ್ಮುಲಾ ಕೊಡೋದಿಲ್ಲ, ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರಲಿ ಅದು. So these are all the examples for the double salts. Now I am going to explain what are the characteristics of the double salts. Double salt ಏನ್ characteristics ಇರುತ್ತೆ? So ಇಲ್ಲಿ ಒಂದು characteristics ನೀವು ಆಲ್ರೆಡಿ ಹೇಳಿ ನೋಡಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ. And remember what type of bond is present and what type of test. ನಿಮಗೆ ಯಾವುದರಲ್ಲಿ ಕ್ವಾಲಿಟೇಟಿವ್ ಅನಾಲಿಸಿಸ್ ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಮಾಡ್ತೀರಾ, ಅಲ್ಲಿ ಟೆಸ್ಟ್ ಗಳನ್ನ ಪರ್ಫಾರ್ಮ್ ಮಾಡ್ತೀರಾ. ಕ್ಲೋರೈಡ್ ಒಂದು ಟೆಸ್ಟ್ ಬರುತ್ತೆ, ಅಮೋನಿಯಂ ಬರುತ್ತೆ, ಸೋಡಿಯಂ ಬರುತ್ತೆ, ಕ್ಯಾಲ್ಸಿಯಂ ಪ್ಲಸ್ 2 ಬರುತ್ತೆ. ಸೊ ಅದರ ಡಿಫರೆಂಟ್ ಟೆಸ್ಟ್ ಗಳು ಇರುತ್ತೆ ಒಂದು ಡಿಫರೆಂಟ್ ಅಯಾನ್ಸ್ ಗೆ. ಸೊ ನಾವು ಡಬಲ್ ಸಾಲ್ಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ತಗೊಂಡಾಗ ಒಂದು ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಇಲ್ಲೇ ಬಂದಿದೆ. ಏನದು ಅಂತಂದ್ರೆ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಗಿವ್ಸ್ ಆಲ್ ದ ಅಯಾನ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದೇಮ್. ನಮ್ಮ ಡಬಲ್ ಸಾಲ್ಟ್ ಅನ್ನು ತಗೊಂಡಾಗ ಅದರಲ್ಲಿ ಎಷ್ಟು ಪಾಸಿಬಲ್ ಅಯಾನ್ಸ್ ಬರೋ ಚಾನ್ಸ್ ಇದೆಯೋ ಎಲ್ಲಾ ಅಯಾನ್ಸ್ ಬಂದ್ಬಿಡುತ್ತೆ when they are dissolved in water. ಸೊ ಅಯನೈಸೇಷನ್ ಆದಾಗ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಪಾಸಿಬಲ್ ಅಯಾನ್ಸ್ ಪಾಸಿಬಿಲಿಟಿ ಅಷ್ಟು ಅಯಾನ್ಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ದಟ್ ಈಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಆಫ್ ದ ಡಬಲ್ ಸಾಲ್ಟ್. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಯಾಕಂದ್ರೆ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ಸ್ ಡಬಲ್ ಸಾಲ್ಟ್ ಗೆ ಡಿಫರೆನ್ಸ್ ಕೇಳ್ತಾರೆ. ರೈಟ್ ಎನಿ ಟು ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಅಂಡ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್. ಅದರಲ್ಲಿ ಪಾಯಿಂಟ್ ಬೇಕಾಗುತ್ತೆ. ಸೊ ಒಂದು ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ದಟ್ ಗಿವ್ಸ್ ಆಲ್ ದ ಅಯಾನ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದೇಮ್. ಅದರಲ್ಲಿ ಇರ್ತಕ್ಕಂತ ಎಲ್ಲಾ ಅಯಾನ್ಸ್ ಅದು ಕೊಡುತ್ತೆ. ಸೊ one simple characteristic that gives all the ions present in them. Under double salt again ions irutte, ella ions barutte. So and another one is what are the ions formed here? So yen ions formation agutte, all those are the simple ions. All those are simple ions. ಅವೆಲ್ಲವೂ ಆಗಿದೆ ಸಿಂಪಲ್ ಅಯಾನ್ಸ್ ಆಗಿದೆ. ಯಾವುದೇ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ಸ್ ಇಲ್ಲ, ಓನ್ಲಿ ಸಿಂಪಲ್ ಅಯಾನ್ಸ್. ಈಗ ನಿಮಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಅಯಾನಿಕ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗ್ತಿದೆ ಅಂತಂದ್ರೆ, ಲೆಟ್ ಬಿ ಟೇಕ್ ಎ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್. ಲೆಟ್ ಬಿ ಟೇಕ್ ಎ ಕಾರ್ನಲೈಟ್. ಸೊ ಕಾರ್ನಲೈಟ್ ಡಬಲ್ ಸಾಲ್ಟ್ ತಗೊಂತೀನಿ, ದಟ್ ಈಸ್ ಡಿಸಾಲ್ವ್ಡ್ ಇನ್ ದ ವಾಟರ್ ಅಂಡ್ ಮೇಕ್ ಇಟ್ ಆಸ್ ಎ ಒರಿಜಿನಲ್ ಸೊಲ್ಯೂಷನ್. ನೀವು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಮಾಡಿರ್ತೀರಾ, ಒರಿಜಿನಲ್ ಸೊಲ್ಯೂಷನ್ ಮಾಡ್ಕೊಂತೀರಾ. ಸರ್ ನಾನು ಒರಿಜಿನಲ್ ಸೊಲ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡು ಒಂದೇನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಮೆಗ್ನೀಷಿಯಂಗೆ ಟೆಸ್ಟ್ ನ ಪರ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ ಸರ್. ಸೊ ಲ್ಯಾಬ್ ಅಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ ಮೆಗ್ನೀಷಿಯಂ ಟೆಸ್ಟ್ ಏನ್ ಮಾಡಬೇಕು ಅಂತ. ಸೊ ಮೆಗ್ನೀಷಿಯಂ ಟೆಸ್ಟ್ ಅನ್ನ ನೀವು ಪರ್ಫಾರ್ಮ್ ಮಾಡಿದಾಗ ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಗಿವ್ಸ್ ದ ಟೆಸ್ಟ್ ಫಾರ್ ಮೆಗ್ನೀಷಿಯಂ, ಯಾವುದು ಕಾರ್ನಲೈಟ್. ಸೊ ಕ್ಲೋರೈಡ್ ಗೆ ಟೆಸ್ಟ್ ಮಾಡ್ತೀನಿ ಸರ್, ದಟ್ ಇಸ್ ಅ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಆಸಿಡ್ ರಾಡಿಕಲ್. ಸೊ ಕ್ಲೋರೈಡ್ ಗೆ ಕಾರ್ಬೋನೇಟಿವ್ ನ ಇಟ್ಕೊಂಡು ಕ್ಲೋರೈಡ್ ಗೆ ಒಂದು ಟೆಸ್ಟ್ ಮಾಡಿದಾಗ ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಗಿವ್ಸ್ ದ ವೈಟ್ ಫ್ಲೂಯಿಡ್ ಸರ್. ಸೊ ಅಗೇನ್ ಪೊಟ್ಯಾಷಿಯಂ ಟೆಸ್ಟ್ ಮಾಡ್ತೀನಿ ಸರ್, ಅಗೇನ್ ಇಟ್ ಗಿವ್ಸ್ ದ ಪೊಟ್ಯಾಷಿಯಂ. ಯಾಕೆ ಅಂದ್ರೆ ದಿಸ್ ಇಸ್ ದ ಸಾಲ್ಟ್ಸ್ ವೆನ್ ದೇ ಆರ್ dissolved in the water they forms the ions. The ionic reactions are very fast. ಯಾಕೆ ನಿಮ್ಗೆ ಇನಾರ್ಗಾನಿಕ್ ರಿಯಾಕ್ಷನ್ಸ್ ನಿಮಗೆ ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ಬರುತ್ತೆ ನೋಡಿ, ಕೆಲವೊಂದು ರಿಯೇಜೆಂಟ್ ಹಾಕಿದ ತಕ್ಷಣ ಇಮಿಡಿಯೇಟ್ ಪ್ರಿಸಿಪಿಟೇಟ್ ಬರುತ್ತೆ. ರೀಸನ್ ಏನಂದ್ರೆ ದ ರಿಯಾಕ್ಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಬಿಟ್ವೀನ್ ದ ಅಯಾನ್ಸ್. ಸೊ ಅದರಿಂದ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಕಾರ್ಬನೈಟ್ ಇರ್ತಕ್ಕಂಥ ಎಲ್ಲಾ ಅಯಾನ್ಸ್ಗೂ ನೀವು ಟೆಸ್ಟ್ ಮಾಡಿ ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಗಿವ್ ದ ಟೆಸ್ಟ್ ಫಾರ್ ಆಲ್ ದ ಅಯಾನ್ಸ್. ಸಿಮಿಲರ್ಲಿ ಫೆರಸ್ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್ ತಗೊಳ್ಳಿ, ಇದರಲ್ಲಿ ಫೆರಸ್ ಅಯಾನ್ ಇದೆ, ಸಲ್ಫೇಟ್ ಇದೆ, ಅಮೋನಿಯಂ ಇದೆ. ಅಮೋನಿಯಂಗೂ ಟೆಸ್ಟ್ ಬರುತ್ತೆ, ಜಸ್ಟ್ NaOH ಹಾಕಿ ನೀವು ಸ್ಮೆಲ್ ನೋಡಿದ್ರೆ ಪಂಜೆಂಟ್ ಸ್ಮೆಲ್ಲಿಂಗ್ ಗ್ಯಾಸ್ ಎವಲ್ವ್ ಆಗುತ್ತೆ. ಸಲ್ಫೇಟ್ ಗೆ ಬೇರಿಯಂ ಕ್ಲೋರೈಡ್ ಹಾಕಿದ್ರೆ ವೈಟ್ ಪ್ರಿಸಿಪಿಟೇಟ್ ಬರುತ್ತೆ, ದಟ್ ಈಸ್ ಇನ್ಸಾಲ್ಯುಬಲ್ ಅಂಡ್ ಡೈಲ್ಯೂಟೆಡ್ HCl. ಸೊ ಅಲ್ಲಿಗೆ ಸಲ್ಫೇಟ್ ಟೆಸ್ಟ್ ಕೊಡುತ್ತೆ. ಫೆರಸ್ ಗೆ ಒಂದು ಟೆಸ್ಟ್ ಇದೆ, ಅದು ಬೇಕಾದ್ರೆ ನಿಮಗೆ ಟೆಸ್ಟ್ ಕೊಡ್ತಾ ಹೋಗುತ್ತೆ. ಅಂದ್ರೆ ಫೆರಸ್ ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್ ಅನ್ನ ತಗೊಂಡು ಅಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಯಾವುದೇ ಅಯಾನ್ಸ್ ನ ಟೆಸ್ಟ್ ಮಾಡಿ 100% ವಿಲ್ ಗೆಟ್ ದ ಟೆಸ್ಟ್. ಎಲ್ಲ ಅಂದ್ರೆ ಅರ್ಥ ಏನಂದ್ರೆ that gives all the ions present in them. At the same time, they give a test for all the ions. Double salts give a test for all the ions. ಏನು ions ಬರುತ್ತೆ ಎಲ್ಲ ions ಗೂ ಟೆಸ್ಟ್ ಅನ್ನು ಕೊಡ್ತಾ ಹೋಗುತ್ತೆ. And one more important characteristic of the double salt is the double salt retain their identity only in the solid state. They retain their identity in solid state only, but lose their identity in the solution state and nothing but dissolved state. When they are dissolved in water, so we can't identify which salt is dissolved in the solvent. Again, once the salt is dissolved, you will get a clear solution. So clear solution ಬರುತ್ತೆ, ಅದು ಯಾವ ಸಾಲ್ಟ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆ, ಆಯ್ತು ಪೊಟ್ಯಾಷಿಯಂ ಕ್ಲೋರೈಡ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆಯಾ, ಮೆಗ್ನೀಷಿಯಂ ಕ್ಲೋರೈಡ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆಯಾ, ಅಮೋನಿಯಂ ಸಲ್ಫೇಟ್ ಡಿಸಾಲ್ವ್ ಆಗಿದೆಯಾ, ಯಾವುದು ಸಹ ನಿಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ವಿ ಕಾಂಟ್ ಐಡೆಂಟಿಫೈ ದ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್. ಅಂದ್ರೆ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಹೆಂಗ್ ಐಡೆಂಟಿಫೈ ಮಾಡಬಹುದು ಅಂದ್ರೆ ಬೇಸ್ಡ್ ಆನ್ ದೇರ್ ನೇಚರ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಅಮಾರ್ಫಸ್ ನೇಚರ್ ಅಥವಾ ಕ್ರಿಸ್ಟಲಿನ್ ನೇಚರ್ ಅಥವಾ ಸ್ವಲ್ಪ ಕೆಲವೊಂದು ಸಾಲ್ಟ್ಸ್ ಏನಾಗಿರುತ್ತೆ ಕಲರಿಂಗ್ ನೇಚರ್ ಇರುತ್ತೆ, ಪೇಲ್ ಪಿಂಕ್ ಕಲರ್ ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಮ್ಯಾಂಗನಸ್ ಸಲ್ಫೇಟ್ ಇಸ್ ಅ ಪೇಲ್ ಪಿಂಕ್ ಕಲರ್. ಸೊ ಅದನ್ನ ಬೇಕಾದ್ರೆ ನಾವು ನೋಡ್ಬಿಟ್ಟು ನಿಮಗೆ ಜಸ್ಟ್ ಒಂದು ಸನ್ ಇದಕ್ಕೆ ಬಿಸಿಲಿಗೆ ಇರುತ್ತೆ, ನಿಮಗೆ ಲೈಟ್ ಪಿಂಕ್ ಕಲರ್ ಕಾಣುತ್ತೆ. ಸೊ ಲೈಟ್ ಪಿಂಕ್ ಕಲರ್ ಕಾಣ್ತಿದೆ ಅಂದ್ರೆ we can easily identify that is definitely manganese sulfate. ನೀವು ಫೆರಸ್ ಸಲ್ಫೇಟ್ ತಗೊಳ್ಳಿ, ಫೆರಸ್ ಸಲ್ಫೇಟ್ ಲೈಟ್ ಗ್ರೀನ್ ಕಲರ್ ಇರುತ್ತೆ. ಅಂದ್ರೆ based on their characteristics we can identify the double salts in the solid state. But when they are dissolved in water, we can't identify which salt is dissolved in that solvent. So the topic is double salts retain their identity in their solid state only, but lose their identity in the solution state or in the dissolved state. That is a very important. So these are the important characteristics of the double salt. One is that gives all the ions present in them and at the same time that gives the test for all the ions. All ions we test na kodta hogutte. So and also that gives the ions, that ions are the simple ions. There is no any complex ions in the double salts, and they retain identity in the solid state but lose their identity in the solution state or dissolved state. Okay, so that is about the double salt. So this is the maximum questions. ನಿಮಗೆ ಏನು questions ಕೇಳಬಹುದು. So ಇವಳ composition ಗೊತ್ತಿರಲಿ, ಮತ್ತೆ what are the characteristics of the double salt, and first of all what is the meaning of the double salt. So ನಿಮಗೆ combination of two simple salts ಅಂತ ಬರೆಯೋಂಗಿಲ್ಲ. So that combination of two simple salts in a perfect stoichiometric ratio. Okay, so that's about the simple salt and known is the double salt. In inorganic chemistry there is another special type of the salt. That special type of salt ಅದು ಯಾವ ರೀತಿ ಇರುತ್ತೆ, so ಅದರ ಪ್ರಾಪರ್ಟೀಸ್ ಏನು that I am going to explain. So there is another type of salt, inorganic salt is present. The salt is of type ಯಾವ ರೀತಿ ಇರುತ್ತೆ, so ಅದಕ್ಕೂ ಮತ್ತೆ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಏನು ನಿಮಗೆ ಡಿಫರೆನ್ಸ್ ಬರ್ತಾ ಹೋಗುತ್ತೆ. There is a special type of inorganic salt. Let me take a simple generally ಒಂದು ಸಾಲ್ಟ್ ತಗೊಂತಾ ಇದ್ದೀನಿ. So that is taken as MLN. And let me take this is X, right? Our X is any one of the ion. क्या टाइम ना आने नहीं आओ तो आने ना क्यों? So अथवा बेरे कलर तो बोले let me take X नहीं करे तो बोलो. So that is MLN ना तो. Remember this is type of the salt. This general तो बोलता है ना example को पायला. So this type of salts ना तो बोलता है when this is on ionization. Now water later ना dissolve मारता है. So that gives the two types of ions. So ಯಾವ ಎರಡು ಟೈಪ್ ಅಂದ್ರೆ, so this complex ಏನು ನಮಗೆ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ, that is called as complex. That is called as complex ಅಂತ ಕರೀತೀವಿ. ಸೊ ಈಗ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಯಾವುದೋ ಒಂದು ಅಯಾನ್ ಬರುತ್ತೆ. ಲೆಟ್ ಮಿ ಟೇಕ್ MnN plus and another one is the X ಅಂತ ಇಟ್ಕೊಂಡು X ಗೆ ಒಂದು ಮೈನಸ್ ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. ರಿಮೆಂಬರ್ ದಿಸ್ ನಾಟ್ ಎ ಹ್ಯಾಲೋಜನ್, ದಟ್ ಸಿಂಪ್ಲಿ ಟೇಕನ್ ಆಸ್ ಜನರಲಿ X ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ. X ಗೆ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಏನು ಮೈನಸ್ n ಅಂತಲೇ ಇಟ್ಕೊಳ್ಳೋಣ. ಎಷ್ಟೊಂದು ಚಾರ್ಜ್ ಇರುತ್ತೆ. ಸೊ ಸಾಲ್ಟ್ ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಆಗಬೇಕು. ಇಲ್ಲಿ ಮೈನಸ್ n ಇದೆ ಅಂದ್ರೆ ಲೆಟ್ ಮಿ ಟೇಕ್ ದಿಸ್ ದ ಪ್ಲಸ್. Okay, so that is MnN plus n and X minus n. So what is the difference here? So let me take the NaCl is a simple soil. When it is under ionization, we will get the two types of ion. One is called as Na plus and Cl minus. And as I said, these two ions are the simple ions, and these two are not simple ions. This is a simple ion, remember, and this is not a simple ion. And what type of ion it is? This is taken as a complex ion. This complex having a charge that is plus n, or it may be having a negative charge, and this ion is called as a complex ion. This ion is called as a complex ion. So this is one of the type of salt. Why it is called as a salt? Because it gives the one cation and one anion. This is a special type of inorganic salt. But when it is dissolved in water, it doesn't give the simple ions. ಅಂದ್ರೆ ಎಲ್ಲವೂ simple ions ಬರೋದಿಲ್ಲ. ಒಂದು simple ion ಬರಬೇಕು, ಇನ್ನೊಂದು complex ion ಬರಬೇಕು. Of course, in some compounds, both the ions are the complex ions. ಆ ಕಾಂಪ್ಲೆಕ್ಸ್ ion ಕ್ಯಾಟಯಾನಿಕ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಆರ್ಯಾನಿಕ್ ಆಗಿರ್ಬೋದು. ಇಲ್ಲಿ ತಗೊಂಡಾಗ ಈ ion ತಗೊಳ್ಬೇಕಾದ್ರೆ ಈ ion ತಗೊಂಡಾಗ ನಮಗೆ ಬರ್ತಕ್ಕಂಥದ್ದು X plus n ಅಂತ ಇಟ್ಕೊಂತೀನಿ. ಇನ್ನೊಂದನ್ನ ಏನು ತಗೊಂತಾ ಇದ್ದೀನಿ MnN minus n ಅಂತ ತಗೊಂಡು. Again, this is taken as a simple ion and this is taken as a complex ion. So now this type of the salts, you salts ಅಂದಾಗ ನಿಮಗೆ ionic ಅಂತ ಯೂಶಲಿ ನಾವು ಹೇಳ್ತೀವಿ salts are ionic in nature ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದ್ರೆ ionic bond ಇದೆಯಾ ಸರ್? ಈಗ NaCl ಅಂತ ತಗೊಂಡಾಗ definitely that is ionic compound, and between Na plus Cl minus there is electrostatic force of attraction. That electrostatic force of attraction between the two ions is called as an ionic bond ಅಂತ ಹೇಳ್ತೀವಿ. So first page the ionic bond is nothing but electrostatic force of attraction between one cation and the anion. So that ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂದ್ರೆ ಏನು ತಗೊಂಡಿದ್ದೀವಿ ಈ ಸಾಲ್ಟ್ ಅಲ್ಲಿ ionic bond ಇದೆ ಸರ್. Of course there are two ions ಇದೆ ಅಂದ್ರೆ definitely there is a force of attraction. That force of attraction is the electrostatic force of attraction. ಅಂದ್ರೆ ಎರಡು ions ಮಧ್ಯೆ ಬರ್ತಕ್ಕಂತ ಫೋರ್ಸ್ ಏನಾಗಿದೆ, that force is called as ionic bond ಅಂತ ಹೇಳಿ. So that why it is called as a complex? ಈ ಏನು ಸಾಲ್ಟ್ ಅನ್ನ ಇದೆ ಈ ಸಾಲ್ಟ್ ಅನ್ನ ನಾವು we can call it as a complex ಅಂತ ಕರೀತೀವಿ ಅಥವಾ coordination compound ಅಂತ ಕರೀತೀವಿ. That is our important chapter, that is called as a coordination compound. Then why you say why can be said as coordination compound? ಯಾಕೆ ಸರ್ ಇದನ್ನ coordination compound ಅಂತ ಕರೀಬೇಕು? The type of the bond between the cationic and anionic. So ಎರಡರ ಮಧ್ಯೆ ಇರತಕ್ಕಂತ force electrostatics and still it is called as ionic bond ಅಂತ ಹೇಳ್ತಾ ಇದ್ವಿ. ಹಾಗಾದ್ರೆ ನಾವು coordination ಅಂತ ಯಾಕೆ ನೇಮ್ ಬಂತು ಇಲ್ಲಿ ಅಂದ್ರೆ remember between the two ions there is a force that is ionic bond, electrostatic bond. But between the metal and other species, ಈಗ ಏನು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಬರ್ದಿದ್ದೀನಿ, ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂದಾಗ ನಿಮ್ಮ ಮೈಂಡಿಗೆ ಬರಬೇಕಾಗಿರೋದು ಎರಡು ಸ್ಪೀಶೀಸ್. ಒಂದು ಮೆಟಲ್, another one is the ligand. So you have to remember the two important terms. One is called as the metal and another one is called as ligand. I will explain about the ligand and types of ligands in the next later. So that is ligand ಅಂತ ಹೇಳ್ತಾ ಇರೋದು, ಒಂದು ಮೆಟಲ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ವಿ. So metal ಮತ್ತೆ ligand ಏನು ಕಾಂಪ್ಲೆಕ್ಸ್ ಒಳಗಡೆ ಇರುತ್ತೆ. So n is that is the number of ligands. Ligand type different type ಬರುತ್ತೆ. It may be monodentate, bidentate, hexadentate, tridentate, different types of ligands are there. But explain later. So ಇಲ್ಲಿ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಏನು ತಗೊಂತೀರಾ that is represented in a square bracket. ಇನ್ನು ಒಳಗಡೆ ಏನಾಗುತ್ತೆ ಇನ್ನರ್ ಸೈಡ್ ಆಫ್ ದಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಇರುತ್ತೆ ಅಥವಾ ಮೆಟಲ್ ಅಯಾನ್ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಏನಾಗುತ್ತೆ ಲಿಗ್ಯಾಂಡ್ಸ್ ಇರುತ್ತೆ. ಲಿಗ್ಯಾಂಡ್ಸ್ ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ಅಟ್ಯಾಚ್ ಆಗೋದಿಲ್ಲ, ರಿಕ್ವೈರ್ಡ್ ನಂಬರ್ ಆಫ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಮಾತ್ರ ಇರಬೇಕು. ಆ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಆ ಮೆಟಲ್ ಆಟಮ್ ಎಷ್ಟು ಲಿಗ್ಯಾಂಡ್ಸ್ ಅಟ್ಯಾಚ್ ಆಗ ಕೆಪಾಸಿಟಿ ಇದೆಯೋ ಅಷ್ಟು ಮಾತ್ರ ಅಟ್ಯಾಚ್ ಆಗಬೇಕು. ಸೊ ಹಾಗಾದ್ರೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ಮೆಟಲ್ ಅಯಾನ್ ಅಂಡ್ another one is the ligand species. Okay, so then why it is called as a coordination bond? So coordination compound ಅಂತ ಹೇಳ್ತೀವಿ. So ಇಲ್ಲಿ ನಾವು ಹೇಳಿದೀವಿ so there are different types of ions. So one is called as a simple ion, one is called as a complex ion. ಇಲ್ಲಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ion ಯಾವುದು ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗಿದೆ. ಸೊ ರಿಮೈನಿಂಗ್ ಏನು ಬರುತ್ತೆ ಸಿಂಪಲ್ ion ಬರುತ್ತೆ. ಅಂಡ್ ಒನ್ ಮೋರ್ ಥಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್, ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಥವಾ ಇನಾರ್ಗಾನಿಕ್ ಈ ಟೈಪ್ ಸಾಲ್ಟ್ ಅಲ್ಲಿ ಎರಡೂ ಸಹ ಸಿಂಪಲ್ ions ಬರಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ಅಟ್ ಲೀಸ್ಟ್ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ion ಬರಲೇಬೇಕು ಅಥವಾ ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ion ಆಗಿರ್ಬೋದು, ಒಂದು ಪಾಸಿಟಿವ್ ಆಗಿರ್ಬೋದು ಇನ್ನೊಂದು ನೆಗೆಟಿವ್, ಎರಡು ಕಾಂಪ್ಲೆಕ್ಸ್ ion ಆಗಿರ್ಬೋದು. That is also taken as salt. And why they are called as complexes or coordination compounds? So remember, between the cation and anion there is a bond, is ionic bond, and between the metal and ligand, that is the bond is called as a coordination bond. So inside the complex ಏನು ಮತ್ತೆ metal ion ಮತ್ತು ligands ಇದೆ. Ligand is a species that can donate a pair of electron, at least a pair of electron that can donate a pair of electron to the metal atom, and resulting bond is called as a coordination bond. So that's why that type of the inorganic salts are called as coordination compounds. That is your chapter, that is coordination compounds. That is called as coordination compounds. One of the important and very important, very logical chapter, that is coordination compound, and very important actually. So between metal and ligand there is a coordination bond. That's why it is taken as a coordination compound. So then what are the properties? So ನಿಮಗೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಎಲ್ಲ ಬರುತ್ತೆ, ಎಕ್ಸಾಂಪಲ್ಸ್ ಹೇಳ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಅಲ್ಲಿ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕ್ಯುಪ್ರೋಮಿಯಂ ಸಲ್ಫೇಟ್, CuNH3 4 times SO4. This is one of the complex. So complex and that's ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? Square bracket ಇದೆಯಾ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ. That is a complex. Inside the complex, remember there is a one central metal atom and remaining species is a ligand. So inside the complex, ಒಂದು metal atom ಏನಿರುತ್ತೆ, metal atom ಬಿಟ್ಟು ಇನ್ ಏನೇ ಸ್ಪೀಶೀಸ್ ಇರಲಿ inside the complex, so ಅದನ್ನ ಎಂತ ಕರಿತೀವಿ, ligand ಅಂತ ಕರಿತೀವಿ. And remaining outer part ಇದೆ, that is counter ion, ಅದೇನು ಅಂತ ಕೊಟ್ಟಿದ್ದೀವಿ ಇಲ್ಲಿ, ಸಲ್ಫೇಟ್ ಅಂತ ಕೊಟ್ಟಿದ್ದೀವಿ. When it is undergo ionization, ಇದನ್ನ ವಾಟರ್ ಡಿಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ. ಸೊ ಡಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಏನ್ ಬರುತ್ತೆ ಸರ್, ಇದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಹೇಳಿದೀನಿ, ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ ಅಂತ ಹೇಳಿದೀನಿ. ಸೊ ಹಂಗಾದ್ರೆ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನ್ನು ಕಂಪಲ್ಸರಿ ಬರಬೇಕು. ಅಂಡ್ ವಾಟ್ ಇಸ್ ದ ಸಿಂಪಲ್ ಆ್ಯಂಡ್ ಫಾರ್ಮ್ ಹಿಯರ್, ದಟ್ ಈಸ್ ಸಲ್ಫೇಟ್, SO4 2 minus. And what is the remaining ion, that is CuNH3 4 times. So ಇಲ್ಲಿ -2 ಇದೆ, ಸೊ ಅದರ ಕಾಂಪ್ಲೆಕ್ಸ್ ಮೇಲೆ ನ್ಯೂಟ್ರಲೈಸೇಷನ್ ಮಾಡೋದಕ್ಕೆ ಎಷ್ಟು ಬರಬೇಕು, +2 ಬರಬೇಕು. And now this is a complex ion, this is a simple ion. ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅನ್ನು ಬರ್ತಿದೆ ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ as a complex, or it is also called as coordination compound. Very simple question. What type of bond is present between sulfate and this complex ion? It's a very important, this is ionic bond. What type of bond is present between the central metal atom and ligand ammonia, that is NH3 ಮಧ್ಯೆ ಇರತಕ್ಕಂತ ಬಾಂಡ್ ಅದು, that is coordination compound, coordination bond. So ಈಗ ಏನಾಗಿದೆ, ಒಂದು ಸಲ್ಫೇಟ್ ಅಯಾನ್ ಬಂದಿದೆ, ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ ಬಂದಿದೆ, then it is taken as a coordination compound. So let me take another example. Potassium ferricyanide, so FeCN6. So this is called as cupromonium sulfate ಅಂತ ಕರೀತೀವಿ. This is called as cupromonium sulfate. That's a common name. So IUPAC name nomenclature is a chapter ಅಲ್ಲಿ almana. So that's common name is cupromonium sulfate, and this is called as potassium ferricyanide. This is called as potassium ferricyanide. So when it is undergo ionization, in the water dissolve ಮಾಡ್ತೀವಿ ಸರ್. So dissolve ಮಾಡಿದಾಗ ಏನು ಬರುತ್ತೆ, that is one is counter and that is K plus. How many K plus are there? 3 K plus ions are there. And remaining another one is the complex ion, that is FeCN6 and 3 K plus ಇದೆ. So charge ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ, ನೀವು ಯಾವ್ದಾದ್ರು ಒಂದು ಸಾಲ್ಟ್ ಅನ್ನ ಕಾಂಪೋಸಿಷನ್ ಬರೀಬೇಕಾದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೆನ್ಪಿಟೇಕ ಅಲ್ಯೂಮಿನಿಯಂ ಸಲ್ಫೇಟ್ ಅಂತ ಹಿಂಗ್ ಬರೀಬೇಕಾದ್ರೆ, ಸೊ ಈ ಅಲ್ಯೂಮಿನಿಯಂ ಏನ್ ಬರುತ್ತೆ, ಇಲ್ಲಿ 2 ಬರಬೇಕು, ಇಲ್ಲಿ 3 ಬರಬೇಕು. ಸೊ therefore salt ಏನ್ ಬರೀತೀರಾ ನೀವು, Al2SO4 thrice ಅಂತ ಬರೀತೀರಾ. ಸೇಮ್ ಥಿಂಗ್ ಹಂಗೆ ಮಾಡಿ ಇಲ್ಲಿ. ಸೊ ಇಲ್ಲಿ 3 ಇದೆ, ಇಲ್ಲಿ ಕಂಪ್ಲೀಟ್ 1 ಆಯ್ತು ಬರುತ್ತೆ, ಇಲ್ಲಿ 1 ಇದೆ. ಸೊ 3 ಆಗಲೇ ಕಳಿಸಿದ್ರೆ ಏನಾಗುತ್ತೆ, ದಟ್ ಈಸ್ ಬಿಕಮಿಂಗ್ ಮೈನಸ್. ಇಲ್ಲ ನಿಮ್ಗೆ ಅದು ಗೊತ್ತಾಗಲಿಲ್ಲ ಅಂದ್ರೆ ಕೆ ಹ್ಯಾವ್ ದ ಚಾರ್ಜ್ ಪ್ಲಸ್, ಸಾಲ್ಟ್ಸ್ ಆಫ್ ನ್ಯೂಟ್ರಲ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಅಲ್ಲಿಗೆ 3 K ಪ್ಲಸ್ ಇದೆ ಅಂತ ನ್ಯೂಟ್ರಲೈಸ್ ಮಾಡೋದಕ್ಕೆ ಒಂದು ಮೈನಸ್ ಸಿಗುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅಗೇನ್ ನೋಡಿ, ಯಾವ್ದು ಹೇಳಿದೆ ನಿಮಗೆ, ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಯಾನ್ ಅನ್ನೋದು ಕ್ಯಾಟಯನ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ನೆಗೆಟಿವ್ ಆಗಿರ್ಬೋದು, ನೆಗೆಟಿವ್ ಆನಯನ್ ಆಗಿರ್ಬೋದು. ಇಲ್ಲೇನಾಗಿದೆ, ಇಲ್ಲಿ ಕ್ಯಾಟಯಾನಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದೆ, ಇಲ್ಲಿ ಆನಯಾನಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದೆ. ವಿಚ್ ಇಸ್ ದ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಹಿಯರ್, ಕಾಪರ್, and here the central metal atom is iron. What is the ligand here, NH3, and here the ligand is Cn. So now that is one of the concept of coordination compound. Then what is the meaning of the coordination compound? And the coordination compound and this, and what is the difference between the coordination compound and double salts? And double salts and the coordination compound ಇರ್ತಕ್ಕಂಥ difference, major difference ಮೂರಿದೆ. So ಅದನ್ನ ಆಲ್ರೆಡಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಬರೆದಿದ್ದೀನಿ, ಅದೇ ತರ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ನಿಮ್ಮ coordination compounds ಬರುತ್ತೆ. So ಹಾಗಾದ್ರೆ coordination compound ಅಂದ್ರೆ, so coordination compound is a salt or a compound in which central metal atom is attached to suitable number of ligands. So central metal atom attached to suitable number of ligands, through which bond, through coordination bond. That type of the compounds or special type of salts are called as coordination compound. I will repeat once again. Coordination compound is a compound or a type of a salt, inorganic salt, in which central metal atom. So ಇಲ್ಲಿ general ಆಗಿ central metal atom attached to required or suitable number of ligands through coordination bond. That type of the compounds are called as coordination compounds. Then what are the characteristics of coordination compounds? Coordination compounds characteristics ಏನು ಸರ್? ಈಗ ನೀವು ಹೇಗೆ ನೀವು ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಗೆ characteristics ಕೊಟ್ಟಿದ್ದೀವೋ ಅದೇ ತರ coordination compounds ಗೂ ಕೆಲವೊಂದು characteristics ಇದೆ. So what are those characteristics? First one. So now it gives all the ions present in them in the case of double salt. But in the case of the coordination compound, it doesn't give all the ions present in them. It gives at least one complex ion. So in for example, let me say potassium ferricin and so in ionize K plus actually FeC annu ionize ಆಗ್ತಾ ಇಲ್ಲ. ಯಾಕೆ ionize ಆಗ್ತಿಲ್ಲ ಸರ್? Fe ಮತ್ತೆ Cn ಮಧ್ಯೆ ಇರತಕ್ಕಂತ ಬಾಂಡ್ ionic bond ಅಲ್ಲ, that is purely coordination bond. So ಅಲ್ಲಿಗೆ Cn ಮೈನಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ. Fe ಯಾವ ಸ್ಟೇಟ್ ಬರುತ್ತೆ? ಪ್ಲಸ್ 3 ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಫೆರ್ರಿಕ್ ಅಂತ ಹೇಳಿದ್ವಿ, ಫೆರ್ರಿನ್ ಅಂತ ಹೇಳಿದ್ವಿ, ನಥಿಂಗ್ ಬಟ್ ಫೆರ್ರಿಕ್ ಪ್ಲಸ್ 3 ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಅಲ್ಲಿ ಅರ್ಥ ಇಲ್ಲಿ ಎರಡು ಅಯಾನ್ಸ್ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ ನಮಗೆ. ಯಾವ್ಯಾವ ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ? Fe ಪ್ಲಸ್ 3 ಬರಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ, Cn ಮೈನಸ್ ಬರಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ಅಂದ್ರೆ it doesn't give all the ions present in them. ಎಲ್ಲಾ ions ಇದು ಕೊಡೋದಿಲ್ಲ. So instead of that, what it give? It gives the at least one complex ion. So double salts gives the all the ions present in them, but coordination compounds are simply called as a complexes, gives at least one complex ion on ionization. That is the one difference. Second, one characteristic. Second characteristic, and it gives at least one complex ion on ionization. Nothing but whether it is only solvent, a particular solvent like water. So that is the one. And second one, so that is the test for all the ions in the head. In the case of double salt, ಈಗ ನೀವು potassium ferricin ಅನ್ನು ತಗೊಂಡು so potassium ಟೆಸ್ಟ್ ಮಾಡಿ 100% ಟೆಸ್ಟ್ ಬರುತ್ತೆ. ಅದೇ Cn minus ಗೆ Fe plus ಗೆ ಟೆಸ್ಟ್ ಮಾಡಕ್ಕೆ ಹೋದ್ರೆ ಟೆಸ್ಟ್ ಬರೋದಿಲ್ಲ. ರೀಸನ್ ಏನಂದ್ರೆ they are not exist as ions. Because between this, the bond is coordination bond, there is not ionic bond. So therefore, ಇಲ್ಲಿ complete ions ಬರ್ತಿಲ್ಲ ಅಂದ್ರೆ ionic form ಬರ್ತಾ ಇಲ್ಲ ಅಂತಂದ್ರೆ definitely ಅದು qualitative analysis ಅಲ್ಲಿ identify ಮಾಡಕ್ಕಾಗಲ್ಲ. Nothing but doesn't give a test for. It does not give a test for all the ions. Test for all the ions. That is the one more. So what type of ions formed in the case of the double salts? Whether dissolved in water, the simple ions. But in the double salt, they are made up of two simple salts. But in the coordination compound, made up of this is consists of made up of at least one complex ion. One complex ion ಬರಲೇಬೇಕು. So ನಾವು ಹೇಳಿದ್ವಿ dissolve ಮಾಡಿದಾಗ complex ion ಬರಲೇಬೇಕು ಅಂತ, ಅಥವಾ it is consists of at least one complex ion. But in the case of the double salts, it consists of two simple salts. That's one more difference. And very important difference between double salt and coordination compound is, in the case of the double salt, that retain their identity in the solid state but lose their identity in the solution state. So but in the coordination compounds, they retain their identity in both solid and solution state. Solution state is nothing but a dissolved state. So how, sir? So usually most of all the complexes or coordination compounds are colored in nature, except some of them are colorless and some of them are colored. So for example, simple example, the one cuproammonium sulfate group. This is one of the dark blue color complex. It's a dark blue color. Solid state of the blue color solid air. When it is dissolved in water, again it retains the blue color. And we can easily identify whether the given salt is a cuproammonium sulfate or not. If solid state of the blue color, so the water dissolve blue color solution, so just by knowing the color, the perfect characteristic so that baby cuproammonium sulfate of that. Then you double salt once potassium chloride or magnesium dissolve, you can't identify because the solution is colorless. ಅದು ಕಲರ್ ಇಂದ ಆಗಬಹುದು ಅಥವಾ ಅವರ ಕ್ರಿಸ್ಟಲಿನ್ ಅಥವಾ ಅಮರ್ಫಸ್ ನೇಚರ್ ಆ ತರ ಬೇಕಾದ್ರೂ ಐಡೆಂಟಿಫೈ ಮಾಡಬಹುದಾಗಿದೆ. ಬಟ್ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಮಾಡಬಹುದು, ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಸೊಲ್ಯೂಷನ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಮಾಡಕ್ಕಾಗಲ್ಲ ಇನ್ ಕೇಸ್ ಆಫ್ ಡಬಲ್ ಸಾಲ್ಟ್. But in the case of the coordination compounds, the retain their identity. You can easily identify that coordination compounds in solid state as well as in the solution state. That is a very important characteristics of the coordination compounds. Then what is the meaning of coordination compound? That is a compound in which The center metal atom attached to us require a suitable number of ligands through coordination bond. Because of formation of coordination bond between the ligand and center metal ion, so we can call it as coordination compounds. So what are the examples? Number of examples are there. So ಮುಂದಿನ week chapter ಬರ್ತಾ ಹೋಗುತ್ತೆ. Simple examples ಕೊಡ್ತಾ ಹೋಗಿದ್ದೀನಿ ಅಷ್ಟೇ. Plutonium sulfate, potassium ferricyan ಅಂತ ಇದೆ. ಇನ್ನೊಂದು potassium ferrocyan ಅಂತ ಬರುತ್ತೆ. Potassium ferrocyan ಗೆ ಸಿಂಪಲ್ ಅಲ್ಲಿ potassium 4 ಬರುತ್ತೆ. FeCN6+. Potassium ferrocyanide, that is K4FeCN6. potassium ferrocyanide. ಇಲ್ಲಿ ferricyan ಅಂದಾಗ Fe+3 state ಅಲ್ಲಿ ಬರುತ್ತೆ. Oxidation state. Ferrocyan ಅಂದಾಗ ಅದು +2 state ಅಲ್ಲಿ ಬರುತ್ತೆ. So these are all some examples for the coordination compounds. Next, what is the differences? Differences so double salts they are made up of two simple salts. One difference. The coordination compounds made up of at least one complex ion. One the difference. They are made up of two simple salts, and coordination compounds they are made up of at least one complex ion. Next, they retain their identity only in the solid state. In the case of double salt. The retain their identity in both solid and solution state. That is in coordination compound. So one more difference in the wonder. So in the case of the inorganic salt, the double salts, they consist of ionic bond. They do not consist of coordination bond. Double salt alli yavude ತರ coordination bond ಬರೋದಿಲ್ಲ. ಅಲ್ಲಿ ಬರೋದು ionic bond. So ಅದರ ಇದರಲ್ಲಿ ಯಾವುದು ಬರುತ್ತೆ ಸರ್ coordination compound ಅಲ್ಲಿ? Coordination compound ಅಲ್ಲಿ ionic bonding ಬರುತ್ತೆ, electrostatic force of attraction ಬರುತ್ತೆ. Addition to that, there is a coordination bond. So the difference ತಗೋಬಹುದು. Double salts ಅಲ್ಲಿ that does not contains any coordination bond. Coordination compounds ಅಲ್ಲಿ they contains coordination bond between central metal atom and ligands. And also they give all the ions present in them. ಯಾವ್ದ್ರಲ್ಲಿ double salt ಅಲ್ಲಿ they give all the ions present in them. Of course they give a test for all the ions. But in the case of the coordination compounds, they give at least one complex ion. They give at least one complex ion on ionization or dissolved in water. So these are the four important differences between coordination compound and double salt. That's a 2 marks question. Write any two differences between double salt and coordination compound. So what is the meaning of coordination compound? ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಈ ಚಾಪ್ಟರ್ ನಿಮಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಕ್ವೆಶ್ಚನ್. ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಬಂದ ತಕ್ಷಣನೇ ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕು. Inside the square bracket there are two species. So one species is called as a central metal atom and another species is called as a ligand. Central metal atom big 2 where ಯಾವುದೇ species complex ಒಳಗಡೆ ಇದೆ ಅಲ್ಲ, that is taken as a ligand. Outside ಇರ್ತಕ್ಕಂಥದ್ದು counter ion. ಅದು ನಿಮಗೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಇರಬಹುದು ಅಥವಾ ರೈಟ್ ಸೈಡ್ ಇರಬಹುದು. And one more you have to remember that complex ಏನಿದೆ that carries charge or may not be carries charge. ಚಾರ್ಜ್ ಕ್ಯಾರಿ ಆಗಿದ್ರೆ ಇದು ಪಾಸಿಟಿವ್ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ಕ್ಯಾಟಾನಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೆಗೆಟಿವ್ ಇತ್ತು ಅಂದ್ರೆ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆನಾನಿಕ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ಚಾರ್ಜ್ ಇಲ್ಲ ಝೀರೋ ಅಂದ್ರೆ ಅದನ್ನ ನ್ಯೂಟ್ರಲ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಆರ್ ದ ಟಾಪಿಕ್ಸ್ ಆಲ್ಸೋ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ ಇನ್ ದ ಫ್ಯೂಚರ್ ಕ್ಲಾಸಸ್. ಸೊ ಇಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕಾದ್ರೆ ಏನಂದ್ರೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಂದಾಗ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಅಂಡ್ ಲಿಗ್ಯಾಂಡ್. ಬಿಟ್ವೀನ್ ದ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಅಂಡ್ ಲಿಗ್ಯಾಂಡ್ ದ ಬಾಂಡ್ ಇಸ್ ಕೋಆರ್ಡಿನೇಷನ್ ಬಾಂಡ್. ಬಟ್ ಬಿಟ್ವೀನ್ ದ ಅಯಾನ್ಸ್ ಇರ್ತಕ್ಕಂಥದ್ದು ಯಾವ್ದು ಬರುತ್ತೆ ದಟ್ ಇಸ್ ಅಯಾನಿಕ್ ಬಾಂಡ್, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್. So that's about the introduction of the coordination compound, salts, simple salts and double salts. So remember, in nowadays there's a major applications of coordination compounds. So under coordination compounds yavinda agutte sir, maximum 99.99% of the coordination compounds are made up of transition elements. They are made up of transition elements. Nothing but D block elements. Almost all the complex ಎಲ್ಲೋ complex almost 99.99% ಎಲ್ಲವೂ ಸಹ ನಿಮಗೆ D block elements ಇಂದ made up ಆಗಿರುತ್ತೆ. And remember, these are also called as a complexes ಅಂತ ಕರೀತೀವಿ. Not only coordination compound, they are also called as complexes and made up of transition elements or simply called as a D block elements. And remember, they are found in nature, especially in the plants and as well as in animals and as well as in the minerals. So natural ಆಗೂ ಸಿಗುತ್ತೆ, plants ಅಲ್ಲಿ ಇದೆ, animals ಅಲ್ಲಿ ಇರುತ್ತೆ, minerals ಅಲ್ಲಿ ಇರುತ್ತೆ, and play a very very important role in almost all the fields. Nowadays coordination compounds ಮೇಲೆ ತುಂಬಾ ರಿಸರ್ಚ್ ಆಗ್ತಾ ಇದೆ and number of applications ಇದೆ. Not only in one field, ಈಗ ಮೆಡಿಕಲ್ ಫೀಲ್ಡ್ ಅಂತ ತಗೊಂಡಾಗ ಮೆಡಿಸಿನಲ್ ಅಂತಲ್ಲ, ಅಗ್ರಿಕಲ್ಚರ್ ಫೀಲ್ಡ್ ಗೆ ಬಂದ್ರೆ ಅಲ್ಲೂ ಸಹ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ಸ್ ದೇ ಪ್ಲೇ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್. ಫೋಟೋಗ್ರಫಿ ಅಲ್ಲೂ ಸಹ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಅಗ್ರಿಕಲ್ಚರ್ ಆದ್ಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಬಯೋಮೆಡಿಕಲ್ ಅಂತ ಬರುತ್ತೆ, ಅಲ್ಲಿ ಬರ್ಬೋದು. ಅಥವಾ ಕ್ವಾಲಿಟೇಟಿವ್ ಅಂಡ್ ಕ್ವಾಲಿಟೇಟಿವ್ ಅಪ್ಲಿಕೇಶನ್ಸ್, ನೀವು ಅನಾಲಿಸಿಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಕೆಲವೊಂದು ಅಯಾನ್ಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕಾದ್ರೆ ಥ್ರೂ ದ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ನಾವು ಅಯಾನ್ಸ್ ಅನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡಬಹುದು. ದಟ್ ಇಸ್ ಕ್ವಾಲಿಟೇಟಿವ್ ಅಂಡ್ ಕ್ವಾಲಿಟೇಟಿವ್ ಅಪ್ಲಿಕೇಶನ್ಸ್. ಅದೇ ರೀತಿ ಮೆಟಲರ್ಜಿಕಲ್ ಅಪ್ಲಿಕೇಶನ್ಸ್, ಮೆಟಲರ್ಜಿಯಲ್ಲಿ ಕೆಲವೊಂದು ಮೆಟಲ್ಸ್ ಅನ್ನು ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ, ಪ್ಯೂರಿಫೈ ಮಾಡಬೇಕಾದ್ರೆ ಥ್ರೂ ದ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಕೋರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ಸ್ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಪ್ಯೂರಿಫೈ ಮಾಡ್ತೀವಿ, ಎಕ್ಸ್ಟ್ರಾಕ್ಷನ್ ಮಾಡ್ತೀವಿ. ಅಟ್ ದ ಸೇಮ್ ಟೈಮ್ ದೇ ಆರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್ ದೇ ಆರ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಅ catalyst. So most of the coordination compounds are also acts as a catalyst for different processes. Andre, not only in one field, the coordination compounds have plenty of applications in almost all the fields, like biomedical or medicinal or agricultural field, metallurgical field, photography, ಅಥವಾ anti-corrosive agents ಅವು ಕೆಲವೊಂದು ಆಗ್ತಾ ಇರುತ್ತೆ. So this are the number of applications, ತುಂಬಾ applications ಬರುತ್ತೆ. In the last of this chapter, ಅಂದ್ರೆ coordination compounds ಅಲ್ಲಿ final ಆಗಿ ನಿಮಗೆ ಬರುತ್ತೆ coordination compounds applications ಇಲ್ಲಿ ಇದ್ದಾಗ so ಎಲ್ಲ applications ಬರ್ತಾ ಹೋಗುತ್ತೆ. So here, so natural ಆಗಿದೆ ಸರ್, ಪ್ಲಾಂಟ್ಸ್, ಅನಿಮಲ್ಸ್ ಮತ್ತೆ ಮಿನರಲ್ಸ್ ಇಲ್ಲಿ ಯಾವಿದೆ? ಸೊ ದಟ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್. ಸೊ ನಿಮ್ಮ ಬಾಡಿಯಲ್ಲೇ ಇದೆ, ದಟ್ ಈಸ್ ಹಿಮೋಗ್ಲೋಬಿನ್. ಹಿಮೋಗ್ಲೋಬಿನ್ ಇಟ್ಸ್ ಒನ್ ಆಫ್ ದಿ ಕಾಂಪ್ಲೆಕ್ಸ್. ಹಿಮೋಗ್ಲೋಬಿನ್ biologically important complexes. So that is hemoglobin. That is iron plus 2 complex. That is the iron plus 2 complex. A role in the limbardi gottirutte. So it carries both oxygen and carbon dioxide throughout the body. So ಅಲ್ಲಿ oxygen supply ಮಾಡ್ತಾ ಇರುತ್ತೆ, heart ಇಂದ ಬೇರೆ tissues ಅಥವಾ cells ಗೆ oxygen supply ಮಾಡುತ್ತೆ, again it carries the carbon dioxide from tissues to heart. So here hemoglobin, that is one of the complex coordination compound, and this is central metal atom is iron and metal ion is Fe+2. This is again a one mark question. So ಅದು ನಿಮ್ಮ competitive exams ಅಲ್ಲಿ ಕೇಳಬಹುದು, what is the oxidation state of iron in hemoglobin? That is +2. That is iron plus 2 complex. And another one is vitamin B12. Vitamin B12, that is also called as cyanocobalamin. Cyanocobalamin. So what is the compound? What is the central metal atom here? Here the central metal atom is cobalt plus 2. Cobalt plus 2. Again, in the competitive example, name the transition element present in the vitamin B12. That is cobalt. That is in the oxidation state plus 2. And one more is chlorophyll. Chlorophyll, that is present in plants. Very important player, very important role in the photosynthesis. And chlorophyll, that is magnesium plus 2 complex. It is magnesium plus 2 complex. Cyanocobalamin is the cobalt plus 2 complex. So similarly, one more, that is cryolite. There is a mineral. So that is the formula Na3Al(F6). That is Na3Al(F6). That is one of the cryolite. This is also mineral ಅಂತ ತಗೊಂತೀವಿ. So naturally ನಿಮಗೆ ತುಂಬಾ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಇದೆ, ಅದರಲ್ಲಿ ಕೆಲವೊಂದು ಮಾತ್ರ ನಾನು ಹೇಳಿದ್ದೀನಿ. That is hemoglobin, vitamin B12, chlorophyll and cryolite. So ಇವು ಸಹ ನಿಮಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಬಂದಿದೆ. ಒಂದು ಕಡೆ ಮ್ಯಾಸ್ಟಿಫ್ ಅಲ್ಲಿ ಕೆಲವೊಂದು ಸ್ಪೀಶೀಸ್ ಅನ್ನು ಈ ತರ ಕೊಟ್ಟು ಹಿಮೋಗ್ಲೋಬಿನ್, ವಿಟಮಿನ್ B12, ಕ್ಲೋರೋಫಿಲ್ ಅಥವಾ ಕ್ರಯೋಲೈಟ್ ಅಂತ ಕೊಟ್ಟು, ಈ ಕಡೆ ಏನ್ ಮಾಡ್ತಾನೆ, ದ ಮೆಟಲ್ ಆಟಮ್ಸ್ ಪ್ರೆಸೆಂಟ್. ಯಾವ ಮೆಟಲ್ ಆಟಮ್ಸ್ ಇರುತ್ತೆ? ಮೆಗ್ನೀಷಿಯಂ, ಫೆರಸ್, ಐರನ್ ಅಥವಾ ಇನ್ನೊಂದು ಅಲ್ಯೂಮಿನಿಯಂ ಅಂಡ್ ಅನೋನಿಯಸ್, ಕೋಬಾಲ್ಟ್ ಅಂತ ಹೇಳಿ ಕಡೆ ಆಪ್ಷನ್ಸ್ ಕೊಡ್ತೀವಿ. ಸೊ ಅಂದ್ರೆ ನಿಮಗೆ ಮ್ಯಾಸ್ಟಿಫ್ ಅಲ್ಲಿ hemoglobin, Fe+2, iron is the central metal atom. So there will be vitamin B12, cobalt plus 2 complex. Cobalt plus 2 is the central metal atom. So next chlorophyll, there is magnesium plus 2 complex. Magnesium is not a deep black element, but still it is formed the complex in the chlorophyll. Chlorophyll complex and magnesium is the central metal atom. So next cryolite in the central metal atom is Al, aluminum, which is a ligand here, that is F, and this is the counter ion. So that are the some naturally occurring and biologically important coordination compounds, especially in movie area. They are biologically very important, play a very important role in the animals and also in the plants. Okay, so that's about the concept and introduction of the coordination compound. So coordination compound and ತಕ್ಷಣ ನಿಮಗೆ ನೆನಪಾಗಬೇಕಾಗಿದ್ದು square bracket. Inside the square bracket there is the central metal atom, that is definitely the black element, and the remaining species ಏನಿರುತ್ತೆ definitely they are called as ligands. ಕೌಂಟರ್ ಆ್ಯನಿಂಗ್ ಆಗಿರಲಿ, ಅಯಾನ್ಸ್ ಚಾರ್ಜ್ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿರಲಿ, ಹ್ಯಾಲೋಜನ್ಸ್ ಗೆ, ಸಲ್ಫೇಟ್ ಗೆ, ಕಾರ್ಬೊನೇಟ್ ಗೆ, ನೈಟ್ರೇಟ್ ಗೆ, ಆ ಸಾಲ್ಟ್ಸ್ ಕರೆಕ್ಟ್ ಆಗಿ ನಿಮಗೆ ಚಾರ್ಜ್ ಗೊತ್ತಿದ್ರೆ ನೀವು ಈಸಿಯಾಗಿ ಕಾಂಪ್ಲೆಕ್ಸ್ ಮೇಲೆ ಚಾರ್ಜ್ ನ ಬರೀಬಹುದು. ಸೊ ಅದು ಮುಂದೆ ಬರ್ತಾ ಹೋಗುತ್ತೆ, ಅಲ್ಲಿ ಎಂಟ್ರ್ ಹೋಗ್ತೀನಿ. ಸೊ ದಟ್ಸ್ ಅಬೌಟ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಸಾಲ್ಟ್ಸ್, ಸಿಂಪಲ್ ಸಾಲ್ಟ್, ದಟ್ ಇಸ್ ಅ ಡಬಲ್ ಸಾಲ್ಟ್, and what are the characteristics of double salt, and one more special type of salt, that is our chapter, that is coordination compound. Competitive exams ಅಲ್ಲಿ ಮಿನಿಮಮ್ 2 ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ. ಮಿನಿಮಮ್ ಹೇಳ್ತಾ ಇರೋದು 100% ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್ ಇದು. ಸೊ ಜೊತೆಗೆ ನಿಮ್ಮ ಥಿಯರಿ ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ So according to the previous, ಅಂದ್ರೆ ನಿಮ್ಮ ಲಾಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಸಿಲೆಬಸ್ ಪ್ರಕಾರ ಬಂದಾಗ 6 ಮಾರ್ಕ್ಸ್ ಕ್ಯಾರಿ ಆಗುತ್ತೆ, 3 ಮಾರ್ಕ್ಸ್ ಗೆ 2 ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ. ಸೊ ಇದರಲ್ಲಿ ಕೆಲವೊಂದು ಟಾಪಿಕ್ ಅನ್ನ ಈ ಚಾಪ್ಟರ್ ತೆಗೆದುಹಾಕಿದ್ದಾರೆ. ಸೊ ದಟ್ ಈಸ್ ಐಸೋಮೆರಿಸಮ್ ಇನ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ಸ್ ಅಂಡ್ ಕೆಲವೊಂದು ಅಪ್ಲಿಕೇಶನ್ಸ್ ನ ಮಾತ್ರ ತೆಗೆದಿದ್ದಾನೆ. ಇನ್ನು ರಿಮೈನಿಂಗ್ ಎಲ್ಲವೂ ಇದೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಇನ್ ದ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಒಂದೊಂದೇ ಟರ್ಮ್ ನ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕಾಗುತ್ತೆ. ಸೊ ನಾವು ವಿಬಿಡಿ ಅಂಡ್ ಸಿಎಫ್ಟಿ, ಕ್ರಿಸ್ಟೋಫರ್ ಥಿಯರಿ, ವೇಲೆನ್ಸ್ ಬಾಂಡ್ ಥಿಯರಿ, ಅವುಗಳ ಥಿಯರೀಸ್ ಅನ್ನ ಸ್ಟಡಿ ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ there are some important terms about the coordination compound. ಆ ಟರ್ಮ್ಸ್ ಬಗ್ಗೆ ನಿಮಗೆ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿರಬೇಕು. ಆ ಟರ್ಮ್ಸ್ ಯಾವ್ಯಾವು ಅಂದ್ರೆ ಲಿಗ್ಯಾಂಡ್ ಆಗಿರ್ಬೋದು, coordination entity, coordination number, oxidation state, central metal ion, what are meant by homoleptic and heterolytic complexes, what is the meaning of density and what type of ligands are there, ಆ ligand speciality ಏನು. ಸೊ ಇದೆಲ್ಲ ಟರ್ಮ್ಸ್ ಜಾಸ್ತಿ ಬರ್ತಾ ಹೋಗುತ್ತೆ. After learning of these terms, then we are going to enter into theories. IUPAC nomenclature ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಥಿಯರೀಸ್ ಬರುತ್ತೆ. ಅಂದ್ರೆ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗಬೇಕಾದ್ರೆ ಯಾವ್ಯಾವ ಥಿಯರಿ ನಿಮಗೆ ಫಾರ್ವರ್ಡ್ ಆಗ್ತಿರುತ್ತೆ ಅಂದ್ರೆ ಒಂದು ಫಸ್ಟ್ ವರ್ನರ್ ಥಿಯರಿ ಅಂತ ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ವಿಬಿಟಿ ಅಂತ ಬರುತ್ತೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ರಿಸ್ಟೋಫರ್ ಥಿಯರಿ ಅಂತ ಬರುತ್ತೆ, ಅಗೇನ್ MOT ಅಂತ ಬರುತ್ತೆ, ಮಾರ್ಕಾಂಡಲ್ ಥಿಯರಿ. ಆ ಥಿಯರೀಸ್ ಎಲ್ಲ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. MOT ನಿಮಗಿಲ್ಲ, ಇನ್ನು ರಿಮೈನಿಂಗ್ 3 ಥಿಯರೀಸ್ ನಿಮಗಿದೆ. ಸೊ ಬಿಫೋರ್ ದಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ಅಬೌಟ್ ದ ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪೌಂಡ್ಸ್. Important terms. The first one, that is ligands. Again, what is the meaning of ligand? So ligand is maybe it is an ion. It is an ion or neutral species. It may be ion or neutral species. So which can donate at least a pair of electrons. ಒಂದು ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ನ ಡೊನೇಟ್ ಮಾಡತಕ್ಕಂತ ಕೆಪಾಸಿಟಿ ಇತ್ತು ಅಂದ್ರೆ ದಟ್ ಟೈಪ್ ಆಫ್ ದ ಸ್ಪೀಶೀಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದಟ್ ಈಸ್ ಅಯಾನ್ ಆರ್ ನ್ಯೂಟ್ರಲ್ ಸ್ಪೀಶೀಸ್ which can donate one or more pairs of electron ಎಲ್ಲಿಗೆ to the central metal atom. ಯಾವುದಕ್ಕೆ? to form complexes. So that is ion or it may be neutral species which can donate one or more pairs of electron to the central metal atom to form a complex. ಒಂದು complex formation ಆಗಬೇಕಾದ್ರೆ ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನ್ ಏನಿರುತ್ತೆ, ಆ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನ್ ಗೆ ಒಂದು ಸ್ಪೀಶೀಸ್ ಏನಿರುತ್ತೆ, that species can donate a pair of electrons to the central metal atom and resulting bond is called as a coordination bond. So ಯಾವ ಒಂದು ಸ್ಪೀಶೀಸ್ ಗೆ ಈ ತರ ಕೆಪಾಸಿಟಿ ಇರುತ್ತೋ that species are called as ligands ಅಂತ ಹೇಳ್ತೀವಿ. So one more important thing is ligand can donate a pair of electrons. That may be a lone pair of electrons or sometimes ligands are negatively charged. So pair of electrons negative charge ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇರಬಹುದು. ಸೊ pair of electrons ಅಥವಾ negative charge ಇರ್ತಕ್ಕಂಥ pair of electrons ನ ಡೊನೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ ಅಲ್ಲಿಗೆ ಈ ligands ಏನಪ್ಪಾ ಅಂದ್ರೆ these ligands are the electron pair donors. We know that in the ionic equilibrium chapter, so different theories are put forward to explain the acidic nature and basic nature, that is acid and bases. One is Arrhenius theory, another is the Lewis concept, and one is the Bronsted-Lowry concept. So among this very important concept, that is what is the Lewis concept. In the Lewis concept, what is the meaning of acid? Electron pair acceptor is called as the Lewis acid. Electron pair donor is called as a Lewis base. And remember, so here the ligands are those which can donate one or more pairs of electrons. Nothing but they can donate a pair of electrons. So hangare ಏನಂತ ಕರೀಬಹುದು? Ligands are called as electron pair donors. Electron pair donors are nothing but Lewis bases. They are called as Lewis bases. Why the ligands are called as Lewis bases? Because they donate a pair of electrons. Electron pair donors is called as Lewis base. So hangare ಇನ್ನೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಏನು? Lewis acid ಅಂತ ಇದೆ. So the Lewis acid ಯಾವ್ದಾದ್ರು ಸರಿ ಇಲ್ಲಿ ಒಂದು ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಅಂತ ತಗೊಂಡಾಗ that metal ion or metal atom is accept the pair of electron from the ligands. ಅಂದ್ರೆ ligand ಇಂದ pair of electron accept ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ this species is taken as a electron pair acceptor. So ಹಂಗಾದ್ರೆ coordination bonds, coordination compound ಅಲ್ಲಿ so then take ಯಾವ್ದು ನೋಡಿದಂತ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳಿ, that is cuproammonium sulfate ಅಂತ ಹೇಳ್ತಾರೆ. cuproammonium sulfate. ಸೊ ಇಲ್ಲಿ ಕಾಪರ್ ಗೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ನಿಮಗೆ ಕಾಪರ್ +2 ಬರುತ್ತೆ. So I will explain how to calculate the oxidation state in future classes. So copper plus 2 ಅಂತ ಇದೆ. So the copper plus 2 ಗೆ ನಾನು ಬೇಕು ligand attach ಆಗಬೇಕು. What is the ligand here? That is ammonia. So ammonia ದಲ್ಲಿ nitrogen ಮೇಲೆ lone pair of electrons ಇದೆ. This is actually a Lewis base. Nothing but it could donate a pair of electron to form a coordination bond. So ಅದರ coordination bond ಎಷ್ಟು ಬರುತ್ತೆ? 4 ligand ಇದೆ ಅಂದ್ರೆ 4 coordination bond formation ಆಗ್ತಕ್ಕಂಥ capacity. So the pair of electron donated by the ammonia, now this is taken as a ligand. At the same time, this is taken as a Lewis base. So that pair of electrons accepted by copper plus 2. Now this copper plus 2 is taken as a Lewis acid. This is taken as Lewis acid. So comparative examples will give you. For example, other complex put. So among the given the complex, the Lewis acid and base is a reactions put. So for the simple complex central metal atom 100% that is acts as a Lewis acid because it accepts the pair of electrons from the ligands. In the remaining central metal atom bit 2 where yav species is a complex olagade, so that species are definitely they are ligands and they are Lewis bases. This is a very simple concept, Lewis base and Lewis acid. At the same time, the ligands are also called as coordinating groups. They are also called as coordinating groups. Another name for ligand, that is called as coordinating groups on the chemistry. So we repeat once again, that is what is the meaning of ligand. Ligand is an ion or a neutral species which can donate one or more pair of electrons to the central metal atom to form a coordination bond, nothing but to form a complex. So ligands are electron pair donors, that's why they are called as the Lewis bases. In the coordination compounds, so Lewis base ಆದ್ಮೇಲೆ Lewis acid ಬೇಕೇ ಬೇಕು electron pair accept ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ. So electron pair ನ accept ಮಾಡ್ಕೊಳ್ಳೋದು central metal ion ಅಥವಾ central metal atom, that is called as Lewis acid. So and also they are called as ligands are also called as coordinating groups. Then what type of ligands are present? So different types of ligands. Types of ligands. Types of ligands. Or classification of ligands. So on which basis we are going to classify the ligands? So here based on the number of donor atoms. Based on number of donor atoms. Based on the number of donor atoms, the ligands can be classified into 3 types. So one is called as monodentate or unidentate ligand. One is called as monodentate or unidentate ligands. So the second one is bidentate or didentate ligands. Second one is bidentate or didentate ligands. Didentate ligands. And the third one is polydentate ligands. Polydentate ligands. So of course, another 2 types. One is the ambidentate ligand and one is the chelating ligand. I will explain later. So here, based on the donor atoms, so you can classify the ligands into 3 types actually. So one is monodentate, another one is the di or bidentate, or another is the polydentate ligand. Then what is the meaning? Simple meaning. You artha ಮಾಡ್ಕೊಳ್ಳೋಕೆ simple ಏನಪ್ಪಾ ಅಂದ್ರೆ ಯಾವ ಬೇಸ್ ಮೇಲೆ donor atoms ಬೇಸ್ ಮೇಲೆ. Monodentate ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ nothing but ligand which consists of one donor atom and which is attached to the central metal atom through one donor atom. So one donor atom ಬೇಕು, ಆ donor atom ಇಂದ ಏನಾಗುತ್ತೆ central metal atom attach ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Nothing but ligand which is bound to the ligand which bound to central metal ion through one donor atom. That is called as monodentate ligand. ಅಥವಾ ಇನ್ನೊಂದು ಟೈಪ್ ಇರಬಹುದು. So the monodentate ligand is the ligand which can donate one pair electron to the central metal atom. ಯಾವುದು one pair ನ ಡೊನೇಟ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ, ಅದು one pair ಡೊನೇಟ್ ಮಾಡಿದಾಗ ಎಷ್ಟು coordination bond ಬರುತ್ತೆ? one coordination bond ಬರುತ್ತೆ. So ಅದು ಸಿಂಪಲ್ ಆಗಿ the ligand which is bound to the central metal atom through one donor atom. It is very simple. ಯಾಕಂದ್ರೆ it is classified based on donor atoms ಆಗಿರೋದ್ರಿಂದ through one donor atom ಇದ್ರೆ ಆ ligand ಅಂತ ಕರೀತೀವಿ. That is called as a monodentate ligand. Then what is the meaning of bidentate ligand? I'll give you examples. So bidentate ligands ಅಂದ್ರೆ so that is the ligand which is bound to the central metal atom through the ligand which bound to the central metal atom through two donor atoms. Through two donor atoms. That is called as a bidentate or didentate ligand. So one more is that is called as polydentate ligand. So polydentate ligand, but it is bound to the central metal atom through three or more donor atoms, which is bound to the central metal atom. The ligand which is bound to the central metal atom through three or more donor atoms. Three or more donor atoms. Here, the bidentate ligand which forms a two coordination bond, and one polydentate ligand, it maybe forms the three or more coordination bonds with the central metal atom. Monodentate ligand, how many coordination bonds are formed by monodentate ligand? Only one coordination bond is formed from the monodentate ligand. Two coordination bonds are formed from the a single bidentate ligand. And three or more coordination bonds are formed by the polydentate ligands. Polydentate ligands are tridentate, tetradentate, hexadentate, pentadentate ligands. One example that is hexadentate ligand. But explain that later. So now, what are the examples for mono or unidentate ligands, which are bound to the central metal atom through one donor atom? Nothing but they are going to form the one coordination bond with the central metal atom. One the pair donor atom, one the coordination bond formation between central metal atom and monodentate ligand. So what are those? So the monodentate ligand or unidentate ligand, that may be neutral or ionic species. So now so I am going to give an example about monodentate. Especially neutral monodentate ligands example. Neutral monodentate ligands. What are those neutral monodentate ligands? Example. So one is H2O. So this is simply called as a water, but remember when it is acts as a ligand, when it is present inside the complex, that is named as a special. So that is special name is aqua. That is called as aqua. Commonly in water the category, but in a ligand and the complex. So in the complex metal atom, water, so that is named as aqua. That's a special name for neutral ligand, that is H2O. It's example for neutral monodentate ligand. So neutral monodentate is charge is zero. Neutral, very charge. And one more is CO, that is called as carbonyl ligand. Usually carbon monoxide, but ligand that is called as carbonyl, and this is having a charge zero. That's a neutral ligand. And one more very important, that is NH3. Simply it is called as ammonia, but when it is acts as a ligand, it is named as amine. So the important thing is amine. There is a difference there. So amine. This is NH2. Amine, double M very. This is very, very important. Nomenclature one complete wrong. So that is when NH3 acts as a ligand, the name is amine. Double M AMMINE. That's one of the neutral ligand. So another one is NO. NO is called as nitrosin. That is called as nitrosin. These are the most repeated ligands in your chapter, that is neutral monodentate ligands. Aqua, CO is called as carbonyl, NH3 is called as amine, when this acts as a ligand only, and NO is called as nitrosin. What are the charge of this ligands? The charge of these ligands is zero. That are the neutral ligands. So similarly, there is one more type, that is negatively charged monodentate ligands. Negatively charged monodentate ligands. So yeah, so first one is, so let me take the Cn minus. This is simply called as a cyanide. So remember, negative ligands are ends with. The name of the negative ligands ends with O. In the end ಮಾಡಬೇಕು IUPAC nomenclature ಮಾಡಬೇಕಾದ್ರೆ ರೂಲ್ಸ್ ಹೇಳ್ತೀವಿ ಬಟ್ ಗೊತ್ತಿರಲಿ ನೆಗೆಟಿವ್ ligands ನ ನೇಮ್ ಮಾಡಬೇಕಾದ್ರೆ whether it may be monodentate or bidentate negative ligands ನೇಮ್ ಅನ್ನು ಏನು ಮಾಡಬೇಕಾದ್ರೆ that name is ends with O. This is cyanide ಅಂತ ಕರೀತೀವಿ but when it is acts in the ligand, that is called as cyanido. The name is ends with O. Next one is NC minus. So here this is called as isocianido. This is called as isocyanide. So what is the donor atom here? In the case of cyanide, donor atom is carbon. Donor atom is carbon. And the carbon in the coalition bond formation of carbon. In the case of NC minus isocyanide, nitrogen is a donor atom. Nitrogen is donor atom. So similarly, one more example, Cl minus. Commonly it is called as a chloride and the chemistry. So the ligand that is named as fluorido. Here the ligand is one ion, so one species that is itself a donor atom. Cl minus is called as a chlorido. Identity F minus is called as fluorido. F minus is called as fluorido. Next, Br minus is called as bromido. Bromido. Next, I minus is called as iodido. That is called as not iodo, that's called as iodido. Iodide and then that is iodido. Name is ends with O. That's another type of negatively charged monodentate ligands. So one more, some other examples. So that is NO2 minus. NO2 minus. So this is called as, there is another ligand that is called as ONO minus. So different sense is there. NO2 minus, ONO minus, same composition about that. The donor atoms are different here. Here the donor atom is nitrogen and here the donor atom is oxygen. So therefore, name nitrito-N. Nitrito-N. Nitrite and the chemistry that ends with O and donor atom is here is nitrogen. So two different same name nitrito that is named as O. So very important, NO2 minus nitrito-N. N is the donor atom. ONO minus nitrito-O. O is the donor atom. Nothing but they are going to form the coordination bonds. Similarly, one more type, that is SCN minus. SCN minus. So this here the donor atom is nitrogen. Here the donor atom is oxygen. SCN minus is called as a thiocyanate. Thiocyanate. Name is ends with O. And one more is there, that is NCS minus. Here to say SCN minus, NCS minus, reverse side was there. So this name is thiocyanate. But other difference in difference is based on donor atom. Here the donor atom is S, that's why it is named as thiocyanate S. And here the donor atom is nitrogen, therefore this is named as thiocyanate N. So one more example, CH3COO minus. This is called as usually acetate and the chemistry, and this is name is ends with O. Therefore, this is called as acetato. Otherity O2 minus and the this is called as oxo. Otherity SO4 2 minus. This is usually called as sulfate, but then the chemistry sulfato. Sulfato. And one more is OH minus. Usually this is called as hydroxide. So there is ends with O. That is named as hydroxido. That is named as hydroxido. So here the thing is, neutral or monodentate ligands name they are special names. In all cases, this is repeated. Even if we just repeat aqua carbonyl NH3. Carbonyl C ಮತ್ತೆ O ಒಂದೇ ಸೈಜ್ ಅಲ್ಲಿ ಬರೀಬೇಕು. ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ನಿಮಗೆ C ರಿಲೇಟೆಡ್ ಬಂದ್ರೆ cobalt ಆಗುತ್ತೆ. This is wrong. So this is carbonyl and this is amine. Double M barbecue. This is very important. And nitrosyl ligand. These are the example for neutral ligand. Charge is 0. And these are example for negatively charged non-dentate ligands. Negatively charged ಇರಬೇಕು. ಕೆಲವೊಂದಕ್ಕೆ ಚಾರ್ಜ್ -1 ಬರುತ್ತೆ. ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ -1 ಇದೆ ನೋಡಿ. ಕೆಲವೊಂದಕ್ಕೆ -2 ಬರೋ ಚಾನ್ಸಸ್ ಇದೆ. So based on donor atom ಕೆಲವೊಂದನ್ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಮಾಡಬಹುದು. ಎಸ್ಪೆಷಲಿ ಈ ಕೇಸಸ್ ಅಲ್ಲಿ NO2 minus, ONO minus, nitrito ಅಂತ ಹೇಳ್ತೀವಿ. Based on donor atom can differentiate. Nitrito N, nitrito O, SCN minus, NCS minus, thiocyanate, thio the sulfur. Thiocyanate S, S is the donor atom. NCS minus, thiocyanate N is the donor atom. So that's about the monodentate, neutral monodentate ligands and negatively charged monodentate ligands. So in the next class, I'm going to explain the bidentate and polydentate ligands. And one more thing, in study material, ಕೆಲವೊಂದು ಬುಕ್ಸ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ನೈಟ್ರೇಟೋ N, ನೈಟ್ರೇಟೋ O ಕೊಡೋ ಬದಲಿಗೆ N ನೈಟ್ರೇಟೋ O ನೈಟ್ರೇಟೋ ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ನಿಮ್ಮ NCERT ಪ್ರಕಾರ ನೀವು ಇದನ್ನೇ ಫಾಲೋ ಮಾಡಿ, ನೈಟ್ರೇಟೋ N ಮತ್ತೆ ನೈಟ್ರೇಟೋ O ಅಂತ ಫಾಲೋ ಮಾಡಿ. ಮೊದಲೇ ಬರೆಯಕ್ಕೆ ಹೋಗ್ಬೇಡಿ. ಸ್ಟಡಿ ಮೆಟೀರಿಯಲ್ ಏನಾಗಿದೆ ಅಂದ್ರೆ N ನೈಟ್ರೇಟೋ O ನೈಟ್ರೇಟೋ ಅಂತ ಇದೆ, ಅದನ್ನ ಕರೆಕ್ಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ನೈಟ್ರೇಟೋ N ನೈಟ್ರೇಟೋ O ಅಂತ ಮಾಡ್ಕೊಳ್ಳಿ ಇನ್ ಸ್ಟಡಿ ಮೆಟೀರಿಯಲ್. Okay, so that's about the monodentate or unidentate ligands. In the next class, I'm going to explain the bidentate and polydentate ligands. Thank you.